Hydrogen fuel cell vehicles and electric vehicles, EVs, are both considered to be alternative fuel vehicles, as they do not rely on gasoline or diesel fuel. A hydrogen fuel cell vehicle uses a fuel cell to convert hydrogen gas into electricity, which powers an electric motor. The main advantage of hydrogen fuel cell vehicles is that they have a longer range than most EVs and can be refueled in a similar amount of time as a gasoline vehicle. However, hydrogen fuel cell vehicles are still relatively rare and the infrastructure for hydrogen fuel is not as developed as for gasoline or electric charging. An EV, on the other hand, stores electricity in a battery and uses an electric motor to power the vehicle. EVs have the advantage of being able to be charged from a variety of sources, including from renewable energy, and the cost of electricity is generally cheaper than hydrogen fuel. Additionally, the charging infrastructure is more developed than for hydrogen fuel cell vehicles. Overall, both hydrogen fuel cell vehicles and EVs have their own unique set of advantages and disadvantages. It depends on the specific use case and personal preference which one is better. Both hydrogen fuel cell vehicles and EVs have the potential to reduce emissions and dependence on fossil fuels, but there are some key differences in the technology and infrastructure. One of the main advantages of hydrogen fuel cell vehicles is that they can have a longer range than most EVs, and can be refueled in a similar amount of time as a gasoline vehicle. However, the production and distribution of hydrogen fuel is still relatively expensive and requires a specialized infrastructure, which is not yet as developed as the infrastructure for gasoline or electric charging. Additionally, hydrogen fuel cell vehicles are still relatively rare, making it harder to find a fueling station. On the other hand, EVs have the advantage of being able to be charged from a variety of sources, including renewable energy. The charging infrastructure for EVs is more developed than for hydrogen fuel cell vehicles, and the cost of electricity is generally cheaper than hydrogen fuel. Additionally, EVs have the advantage of being more widely available and more affordable than hydrogen fuel cell vehicles. In summary, while both hydrogen fuel cell vehicles and EVs have the potential to reduce emissions and dependence on fossil fuels, there are still significant challenges to be addressed before either technology can become a mainstream alternative to gasoline-powered vehicles. Factors such as range, refueling and charging infrastructure, cost, and availability will play a major role in determining the long-term success of these alternative fuel vehicles. Another consideration when comparing hydrogen fuel cell vehicles and EVs is the environmental impact of their production and use. The production of hydrogen fuel requires large amounts of energy and produces greenhouse gas emissions, particularly when the hydrogen is produced from natural gas. Additionally, hydrogen fuel must be transported and stored under high pressure, which also requires energy and has the potential for leaks and spills. On the other hand, the production of EVs and their batteries has its own environmental impact, particularly the mining and processing of materials such as lithium and cobalt. However, as the technology for EV batteries improves, this environmental impact is expected to decrease. Additionally, the environmental impact of EVs can be reduced by using renewable energy sources to charge them. In terms of the use case, hydrogen fuel cell vehicles are well suited for long-distance travel, as they can provide extended range compared to most EVs, and could be a better option for heavy-duty vehicles such as buses, trucks and trains. On the other hand, EVs are well suited for short-distance, urban travel and for people who need a daily commuter car. In conclusion, the choice between a hydrogen fuel cell vehicle and an EV depends on factors such as range, refueling and charging infrastructure, cost, and availability, as well as the specific use case and personal preferences. Both technologies have their own set of advantages and challenges, and it will be important to continue to develop and improve both technologies to make them more viable as alternative fuel vehicles.